CSharpNumerics, a comprehensive numerical library for C#, from theory to code. Today I will talk about our new physics engine. I added the section quantum mechanics, and we added quantum computing gates, and I also added a new quantum engine for building quantum circuits, core algorithms, noise simulation, and error correction, and you can also use reinforcement learning on these circuits. Let's switch to Unity, and here you will see a quantum circuit. I will just clear this, and we start with 1 qubit. So the first gate is just an X gate, NOT gate, and it has the probability that it will always be 1. So where we see we measure probabilities here, so it's the probability is that it's 100% that it will be 1. So we will see this on the Bloch sphere. It's pointing at 1. Let's go back to the circuit, and we can do a measurement, and it will be 1. Let's clear our circuit, and let's test a Hadamard gate. A Hadamard, it's the probability is that it's 1 or 0 is equal. So if we look at the state, we will see in the probabilities diagram here that it's 50-50, but it's 0 or 1. And if we look at the Bloch sphere, it's pointing at the plus. So let's go back to the circuit, and we do a measurement. It could be 1 or 0. In this case, it was 0. Let's clear this. I add a Hadamard gate again, and now I add a S gate. So what the S gate does, it's flip the state 90 degrees on the zeta axle, and you can see this on the Bloch sphere. It was plus, so now it will shift it 90 degrees, so it pointing at plus I. And the state it's 50-50, that is 0 or 1. So I measure here, so it could be 1 or 0. Let's clear this. Now I will increase the complexity, so I add another qubit. Let's see here. Let's select a Hadamard, and then we select a CNOT. It's here, where qubit 0 control qubit 1. This is called the Bell state, and the state here, it could be as we have 2 qubit, they are entangled, so we have 4 states: 0 0 0 1 1 0 1 1. But the result can only be 0 0 or 1, 1. And in the Bloch sphere, as the both are entangled, yeah, they share the information. So the vector is not pointing anywhere. It is in the middle. So let's go to the circuit. And yeah, it can only be 0, 0, and 1, 1. So let's make a measurement on the first qubit. It is 1. So when I make the measurement on the other, it must be 1, as you see. And yeah, now both, because we made the measurement, is pointing at 1. So let us make this even more complicated. We add another qubit. We have a Hadamard. We have a CNOT, where and we add another here. And the qubits can be, yeah, all three is 0 or all three is 1. So exactly like in the Bell state, you will see that the state vector is pointing at the middle origo for all 3 qubits. So if I make a measurement here on 1 qubit, I see this is 1. So the second one will be 1 and the third one will be 1. This was the short demonstration of the quantum engine, and this will be available as a unit asset in a couple of weeks. So thank you for watching.